Hello everyone, welcome back to ptet.chemistry channel. So this is the start of this section B kind of question on topic 4, which deals with stats of matter, but primarily it deals with these gas laws, which include Boyle's law, Charles' law, Avogadro's laws, and of course the ideal gas equation. For those of you who are familiar with these type of MCQ questions, you would know that option A is 1, 2, and 3 are correct. And then 1 and 2 are correct, that's option B. And then 2 and 3 are correct are option C. And only 1 is correct is option D. Okay, so this kind of MCQs assesses as well as tests multiple concepts in A-level chemistry. So it will be a good practice for any kind of A-level students or 16 to 18 years old curriculum, wherever you are in the world really. Okay, so moving on to this first question. It's asking you on, it's basically saying that you have a solid Y, and then you go from the solid to the vapor state. So this is something you call sublimation, and you know that iodine, which is a case study in states of matter, iodine does sublime from a gray solid to a purple colored vapor in the gaseous state. Yeah? So essentially what happens is you get more and more vapor because you start from no vapor because all are solid, okay? And then you increase the temperature, so the solid sublimes and you get more and more gas. But why is the mass constant there? Because no more gas is being produced. No more gas being produced or being formed. So all the solid had turned into the gas, okay? So all solid had gone into the gas at that stage, alright? So when you think about what can be deduced from this diagram alone, if we go straight for option 2, based on what we know about the logic of these options, okay, the pressure of the vapor, constant for all temperature above temperature T. So above temperature T, all of these would be gas, okay, and then the pressure of the vapor was constant. So you don't introduce any more vapor, okay? So it's not like you have more particles. But as temperature increase, the pressure of the gas cannot be constant, because as pressure increase, as temperature increase, pressure will increase, because that is true for constant volume of gas, because you are not producing any more gas, all right? When you think about it, it kind of rings a bell, because as temperature increase, you have more kinetic energy to move around, and therefore you exert more pressure on the walls of the container, so your pressure will definitely increase, and it will not be constant when your volume is constant. There's no more gas being produced, all right? So since 2 is wrong, essentially you only have one choice, which is only 1 is correct. When you think about it, does it make sense or not? The mass of Y used in the experiment was m. You started from m gram of, well, I suppose it's gram, so the mass of the solid is m. All of the solid had gone into the gas. There's no more solid being turned to the gas, therefore mass doesn't change. Mass is being conserved when you go from one state to another, okay? So conservation of mass says that the mass of the gas must be the same as the mass of the solid, so 1 is actually correct. How about number 3? So we know by logic, if 2 is wrong, only 1 is correct, 3 must be wrong. But when you look at the statement, liquid appear at temperature T. At temperature T, all the solid had gone into the gas. There's no liquid involved, because we are talking about sublimation here, solid going to gas, all right, if you read the question. So it's not a problem of liquid at all, okay? Moving on to the next question. So these are basically assumptions of the kinetic theory of gases, which has to do with the gas laws. If we look at the second one, so you will know that the ideal gas equation revolve around a set of laws, one of which is definitely to do with negligible intermolecular forces. Okay, you assume they are 0 or they are minimal. If you have strong or significant intermolecular forces like hydrogen bond or permanent dipoles, then you're going to deviate away from the ideal gas assumption. Then you are going to become less ideal as a result of it, all right? If you look at option 1 now, molecules move without interacting with one another except for collision. So there's one of the assumptions is called perfectly elastic collision. The perfectly elastic collision refers to no loss of kinetic energy. You don't lose any energy at all when you collide, okay? So they don't interact with one another. They don't lose energy in any form at all, except for colliding with each other, being perfectly elastic. So that is correct, okay? Intermolecular distance much greater than the molecular size. The molecular size is volume. Intermolecular distance means the distance between the molecules or the particles, okay, which in this case is saying that they are so far apart. They are so far apart in a big volume, and that is true for ideal gas, okay? So all three of these options are correct. Moving on to this next question. Again, is about what is true for an ideal gas. You got to think about the assumptions, okay? So they love to ask you assumptions in the theory paper when they come up, but they also like to sometimes ask them in an MCQ question if they don't have the opportunity to ask you in the theory paper, yeah? So this second one is basically the same as the previous question, where it talk about negligible intermolecular forces. I'm just using abbreviation because I can, but you got to write out in full in a theory paper, yeah? Negligible volume, that is to do with basically the previous assumption, negligible volume, because they are so far apart, okay? The distance between the molecules, they're so far apart that compared to the volume of the molecule, compared to the molecular size, okay? That's why they're negligible volume. The molecules have an average kinetic energy proportional to the absolute temperature. So we talk about kinetic energy is equal to half mv squared, and then temperature is a measure of kinetic energy. So you know this as part of Maxwell-Boltzmann distribution diagram, okay? So it's a distribution of energy. If you've never heard of Maxwell-Boltzmann distribution yet, don't worry about it. You'll cover this eventually in rate-of reaction. It's to do with temperature being defined as a measure of kinetic energy of the particles, yeah? Okay, so all three of these are correct. In fact, if I go back to the previous question, yep, okay, so there is no mention of kinetic energy there. But yeah, all three of these are correct. Okay, so the option is A. Next question. So they're asking for physical properties, okay? So not chemical properties, yeah? Physical property as a result of hydrogen bonding between water. So you know you can have ice, you know you can have water, you know you can have steam. They are all H2O, but in different state, okay? So ice floats on water because of hydrogen bonded solid. Okay, you should be able to have learned this in school, where you think about the OH2, they are so close together that they form really strong hydrogen bond, okay, with other H2O, where you show the dipoles like that. And then as a result of that, really close together because they're in the solid state, okay? So this is ice. So what happened is this is going to become 109 degree. This is going to become 109 degree. The oxygen, the central oxygen, like tetrahedral. So usually we don't see that in water molecule because in water molecule they are not as close to each other. But in the hydrogen bonded solid framework of ice, okay, ice, they are so close together. And then as a result of this arrangement, it's a hydrogen bonded solid framework, and they kind of increase in volume. We call them expand, okay? So H2O, the structure of H2O, it expands on freezing. When you freeze and form ice, this structure that adopt, it expands. You have so much bigger volume, and that's why it floats on water, because for the same mass, you have much bigger volume. That's why mass over very big volume, you become less dense, all right? Here it says in water, is the bond angle is approximately 104 degree. That is down to VSEPR, which is 2 bond pair, 2 lone pair. So the bond pair, lone pair repel less than, so the lone pair repel more than bond pair, lone pair, repel more than bond pair. This has got nothing to do with hydrogen bond at all, okay? But the floating of ice on water is due to the formation of the hydrogen bonded solid framework. If 3 is wrong and 2 is correct, 1 is definitely correct, and that is true. I'm sure you've seen the really popular this kind of diagram where this is to do with boiling point. You talk about the H2O, H2S, H2SE, H2TE. The only reason why this one is not at the bottom there is a result of hydrogen bonding. Structure and bonding, simple molecular structure. What kind of intermolecular forces exist between the water molecules that you need to break, okay? So only 1 and 2 are correct, so the answer will be B, okay? Moving on to this last question of this 5-question series on the section B question for topic 4. Which are the features of the structure of metallic copper? So metallic copper, it's basically you have copper, I assume it will be copper 2 plus, okay? But of course it could also be copper plus. But essentially what you have is you have an element, so it's only one type of atoms. What you have is you have electrons suspended in between, and you have a positive cations and a negative electrons, not negative ions because you are element, negative electrons and positive cations. You have electrostatic force or attraction, and that is metallic bond. So you have delocalized electron, that is correct. You have a lattice of ions. Electrons are not ions, electrons are electrons. These are metal cations, so there you have a lattice of ions. What you do not have is, you do not have ionic bond. What you have is you have metallic bond. Metallic bond exists between the cations and the electrons because these are elements. Ionic bonds exist between cations and anion. Electron is not anion, okay? Last ionic bond will exist in compound, not elements, okay? So metals are elements. So only 1 and 2 are correct, so answer will be B. This is the end of this 5-question tutorial series. Don't forget to subscribe to the channel if you have benefited from these videos. Don't forget to share this with your juniors if you are in upper 6. Don't forget to share with your seniors if you are in the lower 6. And do share the channel widely as well with many more friends and people you know who can benefit from this channel. Okay, follow me on social media as well so that you can let me know how the videos have helped you, and let me know about your results when you find out about them. Okay, thank you for watching.